So the problem says let R be the region in the first quadrant bounded by the x-axis and the graphs of y equals ln x and y equals 5 minus x. Okay, part A says to find the area. So there's actually two ways you can do this. You can do this with respect to x or with respect to y. So first I'll show you how to do it with respect to x. And to do that, the first thing we need to do is find what this point of intersection is. So to find the point of intersection, you go to your calculator and you put ln x into y1 and 5 minus x into y2. And then you graph it, and it comes out like this. So to find the intersection, you do second trace, and then you push 5 for intersect. And you move your cursor to where it intersects, push enter a couple times, and then this will pop up. It'll give you the x value of 3.693 and the y value of 1.307. Now we can write the integrals. So when we're doing it with respect to x, we have to split up the function down here. We'll find the area below y equals ln x from 1 to 3.693, and then the area below this line from 3.693 to 5. So the integral is the integral of 1 to 3.693 of ln x with respect to x plus the integral of 3.693 to 5 of 5 minus x dx. To plug those integrals into your calculator, you go to Math 9, and then you put in the function, which is ln x, comma, with respect to x, from 1 to 3.693, close parentheses, and the answer you get is 2.132. And now for the other integral, you do Math 9, and you input the function, which is 5 minus x, with respect to x, from 3.693 to 5, close parentheses, and that equals 0.854. And now you add those two areas up, and you find the total area below the two functions, which is the area of the region R, and that equals 2.986. The other way to find the area of the region R is with respect to y. So when you're doing it with respect to y, instead of going this way, you're going this way. So you need to find the area below this function and subtract the area below this function from that. So first you have to change these functions from y equals to x equals. So y equals 5 minus x becomes x equals 5 minus y, and y equals ln x becomes e to the y equals x. So the integral you end up having is the integral from 0 to 3.07, which was your intersecting point and your max y value. And you do this function subtracted by this. So 5 minus y minus e to the y dy with respect to y. And to plug that in, you go to Math 9 and you do 5 minus x minus e to the x. And in the calculator you have to use x because there are no y variables, but it still gives you the same answer. Okay, and then you do comma with respect to x from 0 to 1.307. That gives you 2.986. Now if you look, however way you did it, you end up getting the same answer of 2.986 for the area of R. So part B says region R is the base of a solid. For the solid, each cross-section perpendicular to the x-axis is a square. Write but do not evaluate an expression involving one or more integrals that gives the volume of the solid. So the cross-sections are squares. So a square, the area of a square is just one side squared because they'll equal the same thing. But because this function, because this region is two functions, the y value, or the length of the side of the square, is going to vary depending on where the x value is. If the x value is below 3.693, the y value will equal ln x. If the x value is above 3.693, the y value will equal 5 minus x. So for this problem, we're going to be using the integral from part A that was with respect to x. But we're going to be tweaking it a bit. To find volume, you just integrate area. So we're taking the integral from 1 to 3.693 of ln x squared dx plus the integral of 3.693 to 5 of 5 minus x squared with respect to x. And because that question said just to write the expressions and we don't have to evaluate, this is all you need for part B. Finally, part C says the horizontal line y equals x divides R into two regions of equal area. Write but do not solve an equation involving one or more integrals whose solution gives the value of k. So the problem is basically saying that there's going to be a line, a horizontal line of y equals k, a certain constant, and we want that line to cut this region R exactly in half. So what we're going to use is the integral from part A, but we're going to use the one that was with respect to y. So we want to take the integral of 0 to k, whatever constant that y is going to equal, of 5 minus y minus e to the y dy, and we want that to equal half the area of the region R. So we set it equal to 1/2 times 2.986. Once again, we don't need to find the actual value of k for the answer. The problem only asks for the equation and the integral, so this is it. That's it! Yay!